This video is Unit 1, Transformations, Learning Target 1A. You can perform transformations including translations, rotations, and reflections, or a composition of any of those. So I'm going to share my screen and let's just talk a bit about translations really quick before we jump into reflections. So I feel like you got a pretty good understanding in class about how translations works. But let's just say, I'm going to cover up these directions here, and let's just say that I wanted to translate this point. I want to go to the left by 3, and I want to go down by 5. All right. You've got this really simple. You're just going to take this point. You're just going to go 1, 2, 3. And you're going to go 1, 2, 3, 4, 5. And you're going to make the new point. The new point is going to be the image. So let's say that this is point A. The way that I'm going to label this one is A prime. I just put like a little dash up there, like a little quote up there. And that is my image of the original. So I've translated it left 3 and down 5. So let's see where we are. I could just calculate this and go, oh, on the x-axis, we're at 1. And then on the y-axis, we're at -1, 2, 3. But if you didn't have the graph there, you can translate this point just by using the numbers, right? So I'm going to take 4, 2. And that's in the form x, y. X always comes first in the alphabet before Y, and so I always put that one first here. So if I wanted to go to the left 3, that is a transformation, or it's being translated in the X direction, all right, back and forth, right? So I'm affecting the X values there. So I could just come down here and go, oh, well, that's like 4 minus 3. Why did I do minus? Minus because it's going in the negative direction. It's going left. If it were going to go right, that would be in the positive direction, and I would add. We do the same thing with the 5. The 5 is going down. So anything that's up or down is on the y-axis in the y direction. So this is going down. Down is also a negative direction. Again, if it were going up, that would be positive, right? So I'm going to go 2 minus 5. And you can see 4 minus 3 is 1, and 2 minus 5 is -3. Super easy. So now you have a rule for this, where however you're translating it, you are going to be subtracting from x or adding to x, or subtracting from y or adding to y. And that is in the notes under translation on our Canvas page. So I'm just going to get rid of the image. And here we go. We want this point 4, 2, and I've called this point A, which is 4, 2. I want this reflected over the x equals y axis, all right? Now, if it says reflected over the y axis, I'm just going to grab this axis right here, and I'm just going to figure out how many it is on this side, and I'm going to count that many over on this side. Really super simple. 1, 2, 3, 4. So then I would go 1, 2, 3, 4, and I'd put that there. But this one is reflected over the x equals y axis. That is the one that goes through when x equals y, when x is 1, y is 1. And there's that little spot. When x is 2, y is 2. And there's that spot. When x is 3, y is 3. And there's that spot. So that creates this line over the x equals y axis. Okay. Similarly, I could ask you to reflect it over the negative x equals y axis. And in that case, it's just going to go, instead of going this way, it's going to go this way, and it's going to be that line the other way, directly at a 45-degree angle. So for this one now, I want to reflect this over this axis. So that means if I were to fold this paper right there, if I were to make that a fold, which I have a really hard time doing with the way that it's bound, but if I were to fold this, wherever that touches on the other side, that would be my new point. But I could try folding. I'm just going to see if this works. All right. I'm going to reflect it over this line, and it is here. And I have like some grid lines there. And I have some grid lines here. I wish I had some patty paper, but it's all good. It's not perfect, but it's fine. So now if I fold it right on that line, let's see, can you see it? Not very well. I can see the grid a little bit on mine. So like I can see that the grids are here and here. And I can see my dot is right here. Oh, you can see it there. So if I put this here back onto this line here, you can see if I fold it over, it has gone, let's see, my line is not, it's not pretty. Okay. You can see from this point to my new point, it has gone up 2 and over 2. So this was at 4,2. And now I'm going to take my y values and I'm going to go up 2. I'm going to add 2 to this, so it's going to come up to 4. And then in my x values, it looks like I went back 2. So I'm going to go 4, 3, 2. What just happened there? Oh my gosh. It looks like my x value became my y value. And my y value became my x value. And that is exactly the formula for this. So if you reflect over x equals y, then your original point, x comma y, moves to its image, y comma x, which is kind of crazy. It's kind of crazy. If you want to reflect over just the y-axis, let's pretend like we did that. You want to reflect over just the y-axis. What happened to my x values and y values? So over y-axis, xy. Well, when it came out here and then I went over this way, I was only 4 away. So again, I'm reflecting over the y-axis right now. Only 4 away. So my x values aren't going to change. I'm just going to go 4 away on the y values. I'm going to go 1, 2, 3, 4. And this time they were just in the negative direction. So my x, or my bad. I was saying x and y. They're actually swapped. All right. My x value was 4, not my y value. My x value was 4. And when I went over to the other side, my x value became -4. My y values are the ones that never changed. I never went up or down. So really, I kept that. So the image of A, when I reflect over the y-axis, here, my x value becomes negative, and my y value just stays the same. So there's a rule for reflecting over the y-axis. All right, enough about reflections. All right, last question. So here we have triangle ABC, and it's rotated clockwise 90 degrees. They want to know the new coordinates of vertex B. So just this point, just B. It doesn't necessarily have to be that you do the entire triangle. Now you could get a question where they ask, you know, what does the triangle look like now? But one of the questions might just be, what are the coordinates of vertex B? So again, I just like drew this little thing because I do love patty paper. And I put this over, and what was this? 3, -2. And I'm not doing B yet, I'm just doing C as an example. So it's rotated, they want to go clockwise, clockwise. So we are going to go clockwise like the clock. I'm going to unstick this. I'm going to rotate it about the origin. And I'm going to restick this little paper here. And let's look and see what happened. It's not absolutely perfect, but now this point is at -1, 2. And then it came down 1, 2, 3. So what happened there? What happened there? Okay, this 3 -2 are confusing me. So I went from 3, -2 to its image, -2, -3. What happened there? Ah, I think I see it. Oh, it's hard for you to see. You don't see it, do you? Okay, so X, Y. I think it's really obvious. The Y got put in place of the X value. So, oops, the Y got put in place of the X value. And then this other one's a little bit more difficult to see. It does move over here, right? The X gets put in place of the Y value. They swap, but this 3 becomes negative. And in fact, that's the rule. And all of these rules are written on your, they're posted for you in Canvas on the homework assignment page. All the rules of all the transformations are there. So if I move this point, C, the image of C goes over to -2, -3. So if I want to use this formula and I want to find point B instead of trying to use my piece of patty paper, right? Then what I'm going to do is I'm going to use the formula. I'm going to say -2, -2. That is my X, Y. And the formula for rotating clockwise 90 degrees is to just swap the order of X and Y. And the X becomes negative. All right, so let's do this. They're both the exact same number, so I'm just going to swap them, which is going to look exactly the same. And then I just need to change the sign on this one here in the place of the Y value that was the X before, all right? So instead of negative, it's just going to be positive. So when I write my answer, when I type my answer into Canvas, I'm just going to say parenthesis, -2, 2, close parenthesis. And that is how you do rotations clockwise. Real quick, I want to make sure that I share with you, that I show you where these are located on the page. So here I have this pulled up just in case. This is in our 1A assignment, Unit 1, Transformations. And then here they are, the translations going from left to right or up or down, right? The reflections over the x-axis, the y-axis, either the y equals x-axis or the y equals negative x-axis. Even if you don't graph any of these, if you're very good at moving x values and y values around, you can also do it algebraically. And then the rotations, like we just did rotation 90 degrees clockwise. We did this first one, and notice it's the same thing that we got. X and y get swapped. It goes y to x, and then we change that sign on the x. It gets put into that second place. So if you need to look those up, feel free to look those up while you're taking the quiz. And I hope this video helps.